Warning: the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This is a third and final video on a series that is reviewing solving nonlinear inequalities. We started with solving quadratic inequalities, then we moved on to rational inequalities. This video is focused on absolute value inequalities. Believe it or not, these are very important in calculus. We're first going to start with a review of the absolute value function. The absolute value of an expression, and I just have a little circle with a bar in it, is the piecewise defined function. Absolute value of that circle bar is equal to, well, I'm going to do this a little bit backwards because I've written it backwards, but if that circle bar was already non-negative, it's greater than or equal to 0, then there's no need to have those absolute values. You could totally take them off, right? So if I said, what's the absolute value of 3? Because 3 is already positive, you don't need those absolute values. You could totally rip those off. On the other hand, if that circle bar was negative, well then, we need to force it to be positive. That's what the absolute value is going to do. It's going to force that circle bar to be positive. And the way it does that is it takes the opposite of circle bar. The opposite of the negative value forces it to be positive. This is the legit and real definition of the absolute value. By the way, that symbol, circle bar, is just a black box for whatever expression you've been given. So it doesn't have to be a circle with a bar. It could have been x, or it could have been 5x plus 27 or something like that. Once you have that definition in hand, solving an absolute value inequality is actually pretty simple. Take a look at this guy right here. It is an absolute value inequality. Just like any inequality, or equation for that matter, you want to start isolating the term involving the variable. So let's go ahead and subtract 4 from both sides, and I'll zoom out for that. And then divide both sides by 3. Be very careful when working with inequalities. If that 3 was negative, the inequality sign would flip when you divide both sides by that -3. But luckily, it's positive. Now that we've arrived at this point right here, I'm going to then invoke the actual true definition of the absolute value. And remember, the absolute value of something splits into two possibilities. If the argument of the absolute value is not negative, then you don't need those absolute value signs. It's already non-negative. So in that case, it will just return the argument. If on the other hand, the argument of your absolute value is actually negative, then you need to force it to be positive, because that's what the absolute value is going to do, by placing a minus sign in front of it. And that would force the negative value of 2x minus 1 to be positive. But here's the deal. Do you happen to know what 2x minus 1 is? Is 2x minus 1, the argument of that absolute value, is that positive or is that negative? Is this stuff right here positive or negative? Well, you don't know, because x is a variable. And in fact, for certain values of x, like 2, that will be positive. But for other values of x, like -2, that's going to be negative. And because nobody told us what x is, we have to look at both of those possibilities. So zooming out, if 2x minus 1, the argument of the absolute value, is not negative, in other words, if it's greater than or equal to 0, then we have the following for our inequality. In other words, I could just rip off the absolute values because, well, 2x minus 1 is not negative. If on the other hand, 2x minus 1 was negative, then our inequality can be written as the following. We can remove those absolute values and replace the given statement with the opposite of 2x minus 1. Let's work on the black ink here, this inequality first. We'll just add 1 to both sides. We get that x is less than or equal to 2. So that is one set of solutions. You can graph that out if you want to. I have shaded in where x is less than or possibly equal to 2. Now in blue, the other case, if 2x minus 1 were negative, well then we have the opposite of 2x minus 1 is less than or equal to 3. Multiplying both sides by a negative, we get that 2x minus 1 is greater than or equal to negative 3, and it's greater than because, well, we multiplied both sides by a negative number. The inequality switches. Otherwise, the rest of it is just solving like any algebra problem. And we get that x has to be greater than or equal to a negative 1. Let me draw that down. Now this actually would confuse me when I was a student. I totally remember these problems because I couldn't remember, do you intersect these two intervals? Is that the solution? Or is it the union of these intervals? Is that the solution? Well, if you're like me and you really question yourself quite often when you're trying to do a problem like this, that's how I was when I was a student. I would build a single number line and I would mark those two values on that number line, and I would just test the inequality. You can actually just test this one right here for values in those intervals. For example, I'll test a value that's below -1, I'll test a value that's between -1 and 2, and then I'll test a value that's greater than 2. This is probably the safest way of doing this. So think of a number that's less than -1 and plug it in. So like -2. -2 is definitely less than -1, and if you were to plug -2 into that inequality, you would get the following. Absolute value of -2 times 2 minus 1, which we know is the absolute value of -5, which we know is 5, which we know is not less than 3. So therefore, in that interval from -infinity up to -1, our inequality will not work. Now try a value between -1 and 2, and obviously 0 is a perfect value to try. So I go back up to this inequality here and I plug in 0. I'd get the absolute value of -1, which is 1 by the way, and that's definitely less than or equal to 3. So our inequality works in this region right here. Now plug in any value greater than 2 into, again, this inequality. I'll plug in maybe a 5. If you plug in a 5, you get 2 times 5 minus 1. That's going to be the absolute value of 9, or 9, and that's definitely not less than or equal to 3, so we will not include this region. So this tells me that it's going to be the intersection of these two highlighted intervals. It's just going to be this interval right here. Now I can include the edges because we are asking when is this less than or equal to. That or equal to means that I can include those edges. And again, when you're answering an inequality question, you generally want to answer using interval notation. So our solution would be the interval from -1 to +2, including both endpoints. And it depends on instructor and what you're using, but some people write it this way as well. X is an element of the interval from -1 to 2. Either way of writing it is perfectly fine to me, but just letting you know, you might have an instructor that forces you to write this X is an element of. That just means you're willing to accept, or the solutions are any X value in the interval from -1 to 2, including -1 and including 2. Let's go ahead and see what happens with applications and absolute value inequalities. In fact, that's where absolute value inequalities really shine, is in applications and manufacturing and stuff like that. Also, by the way, in theory with calculus. So let's read the question. A company manufactures industrial laminates, which are thin nylon-based sheets. You can think of this as maybe like a company produces sheet metal or aluminum foil or something like that. And they require the thickness to be 2/100ths of an inch, with a tolerance of 3/1000ths of an inch. Those two pieces of information are going to be so critical, I'm going to highlight them. So that's our intended thickness, but we're allowing a tolerance because, come on, it's not going to be perfect. A machine is doing this. It's not going to be spot on. It'll get close though. Find an inequality involving absolute values that describes the range of possible thicknesses for the laminate. Well, let's go ahead and do that. We're going to let T be the actual thickness of what's being produced. Now remember, T is definitely not always 0.020. It's not 2/100ths of an inch. It's close, but it's not going to always be 2/100ths of an inch. But we're okay with that. We allow a little wiggle. Think about this. If your target is 2/100ths of an inch, you're willing to accept, let's say that's our target, you're willing to accept a wiggle room of up to 3/1000ths of an inch away. In other words, add 3/1000ths or subtract 3/1000ths, and you're willing to accept thicknesses within that interval. And it is often asked to me, wait, do we include those endpoints or do we not? Well, if it was my boss and my boss said, well, I'm willing to allow up to 3/1000ths of an inch in error, that tells me that they're including that edge as part of their error. They're willing to accept values at those extremes as well as all values between. So this is a list of all possible thicknesses that are acceptable. Notice that picture makes it very easy to write down an interval that is representative of all the thicknesses we can get. So the thicknesses we're going to allow are thicknesses in the interval from 0.017 inches to 0.023 inches. That should not be mind-blowing. That's actually the answer to part B. But we're still focusing on part A. We want to write an inequality involving absolute values that describes a possible range of thicknesses for the laminate. This requires us to remember something about absolute values that you may or may not have known from the past. The absolute value of A minus B is the distance between A and B. You can test that out. The absolute value of 3 minus 5, that is going to be 3 minus 5 or -2, but the absolute value of that is 2. That's actually the distance between 3 and 5 on a number line. If you want to write it the other way around, well, the distance between 5 and 3 is still 2. They're still 2 units away from one another. If you're interested in negative numbers, 7 minus a -2, let's just say, that's the distance between 7 and -2 on the number line. Well, 7 minus a -2 is 9. The absolute value of 9 is 9, and that is actually the distance between 7 and -2. It's a 9-unit distance. If you wanted to write it the other way, again, that's just the distance between -2 and 7. -2 minus 7 is a -9, but an absolute value of -9 is 9. So again, shows us the distance between -2 and +7. That I'm telling you because we want to know the distance between this central point here and our actual measured thickness. Let's say that this is our measured thickness right here. We want that distance there to be less than 3/1000ths. Again, let me say that all of our thicknesses that we produce for these sheets of laminate can be any value of T in here. The main concern is that the distance between that thickness, whatever we're working with, and the desired thickness be less than 3/1000ths of an inch. We desire a thickness of 2/100ths of an inch. The real thickness that we get, well, the difference between that real thickness and 2/100ths should be maximum of a 3/1000ths of an inch. So, how do you write that as an inequality? We want the distance between the thickness that we create and the thickness that we want to be less than or equal to 0.003 or 3/1000ths of an inch. That is the inequality we're searching for. And I'll actually write that down in language down below. The distance, and I put that in quotes because we're really talking about thicknesses, but the distance between the thickness of our produced laminate and the ideal thickness, which is 0.02, is allowed to be up to 3/1000ths of an inch. That style of problem is really critical to understand as you step into calculus, because calculus involves this style of absolute value inequality. However, in calculus, you don't include the edges, so you don't actually have that equality there, but for now, we'll just include it. It is the basis for something that is called a limit. You don't need to know that right now, but I'm just letting you know that's the basis for the theory of most of calculus. But again, I don't require that you know that right now. What is important is that you follow this example as much as possible, and you can solve absolute value inequalities. Well, that does it for this video. I hope that it was somewhat understandable, and I hope to see you again in a future video.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry. Don't whine. Just